Hello and welcome to Practice Problems Chapter 7. In this video we're going to be talking more about confidence intervals here. Now I will preference that we're going to mostly be focusing on confidence intervals when it comes to a z-value and a known population standard deviation, but I know our book likes to throw a couple more tests at you with t-tests and chi-squared a little earlier than where we are now. So I'm going to be going through kind of both of them, but for the majority of this packet, we're going to try to stay with just an x bar and a known population standard deviation. If you don't know a population standard deviation, then we're going to be using a t-test. And as those come up, I'll point them out for you, and it just for your thing. But for right now, we'll be doing that and just make a note of it, mental note that when we do, when we're trying to find values, if you don't know a population standard deviation, then we're going to resort to using the t-table, and we haven't really gotten there quite yet. But it's very similar to z and t. It's just about whether or not we know the population standard deviation. So once again, assuming that you've gone through this a little bit and you're coming here to review, make sure you have a better understanding, fine-tune, going from there, we're just going to jump right in. One thing we do know is that with problem A is we have our sigma, which if we know sigma there, that is a population standard deviation, so clearly it's known here, so we're going to be using a z-value, and our x bars from the sample. So I'm going to come up here and give us our x bar from our BMI is going to be 26.9833, n equals 6. Up here, down below, we want to calculate 95% confidence interval, knowing now that we have a mean and a standard deviation. We can go from there to make a confidence interval. With this, it's going to be x bar plus or minus e, where e is going to equal our z of alpha over 2. So remember, z underscore alpha over 2, so that's going to be like our z percentile we're finding, times what's called the standard error of the mean, which is the standard deviation over the square root of n. When we're trying to find our z of alpha over 2, since we have confidence at 0.95 or 95%, alpha is going to be what create, 1 minus confidence equals alpha, 1 minus alpha equals confidence. Confidence in alpha is going to sum to 1. So if you know if confidence is 95%, our alpha is going to be 5% or 0.05. Our z of alpha 0.05, or 95%. One of those values probably could write down right on the side. It's going to be 1.96. Standard deviation given to us here at 3.705 divided by the square root of n, calculated above 6. When we write all this out, we're going to get 26.9833 plus or minus 2.9645, right? So this is our x bar plus or minus our error, and we're going to get a value of 24.0188, comma 29.9478, and this is our confidence interval for being at the 95% confident. To save some time, I did a little bit of writing. So part B is, do we correctly interpret the interval? And we would say we are 95% confident the true interval from 24.0188 to 29.9478 actually does contain the true value of mu. That's probably the best handwriting you'll ever see me do. You're welcome for doing that. And as we go through, I wrote out the other ones too. It's also just to save time because that takes me a lot of time to write that out. You can find how to correctly interpret the interval in the book. They have a very just specific way of writing it. It's just like this. Big thing is always to take into consideration when we're writing it. We always want to go from our lowest value to our highest value. Don't flip-flop them around. We just want to be in order there. Number 2, a correct interpretation of confidence interval could portray information on significance of an observed estimate. Is true. Now, number 3 here, we're given, use the given confidence in statistics to construct a confidence interval for our population proportion here. So when we're doing our population proportion, we're going to be taking, this is going to take a little bit of room to write out here, so I'm going to kind of all over. So our p hat plus or minus e, and when we are looking here, we have an n, x, and 95%. We can construct our p hat to being 0.8307. When we want to find the value of e, e is equal to our z of alpha over 2 times the square root of p hat times q hat over n. So n, or p being the probability of success, q being the probability of failure. We know the probability of success is going to be 0.8073. Probability of failure is going to be 1 minus that. So when we take our z of 1 minus alpha over 2, 95%, so we know it's going to be 1.96 times the square root, 0.8307, that's our p hat. Our q is going to be 1 minus that, which is going to be 0.1693, all over n, which is given to us as 195. Value all this out, we can get 0.0525. So our p hat plus or minus e, so if our p hat is 0.8307 plus or minus our e of 0.0525, when we write all this out, we will get our value of A. Moving along, we're going to find the value of Z, alpha corresponding to confidence level of 89.48. The book grades it like this. I think it's a little easier if you always take Z alphas, or that Z percentile to be 1 minus alpha over 2. Because if we do with the Z alpha over 2, we kind of need to take the absolute value of it, just especially when we're moving very, very high confidence interval. I like doing 1 minus alpha over 2. I think you'll kind of get a better answer and move that forward. And when you do that, we're finding really the Z, or when we get our Z value, you're either getting it the absolute value of Z of 0.0526 worked out, or 1 minus that value. And kind of the way you look at it, you can get to the book, and if you do a 0.0526, it'd be negative 1.26, but if you take the absolute value, then it's 1.26. That is the way I normally go about solving it for it. Find your alpha. Remember, if you have a confidence, 1 minus your confidence is going to be equal to your alpha level. All right, moving along, number 5, we want to be filling in the letters that corresponds to the blanks, and you want to round the value of n up to the next larger whole number when we're dealing with sample size. Remember, when you're finding a value of n, always round up, even if your value is like 5.02. When we calculate this, we're saying that we need, like 2% of a person. Well, we clearly can't get 2% of a person, but we can't go down to 5 because it needs to be above 5, even just slightly above 5. So you always want to round that up. So we're going to be rounding that up to 6. And as we always say in statistics, we want more and more people. People can drop out of a study voluntarily. People can die in studies. Many different ways people can just, drop out. They just, don't want to be in a study anymore. So we always want to round values or for sample size definitely up in whole numbers. Even, like I said, even if it's just 2% of a person, we always want to round those up in larger whole numbers. All right, moving on here to number 6. We want to fill in the blank for a critical value of alpha over 2 corresponds to blank confidence. One of those numbers that we just kind of will know at 2.33, but when we're dividing it by 2 for a confidence interval, it's going to be 98. So if we went at 2.33, we'd find that the that would be like 0.99 in the probability, but then we take our alpha and then divide it by 2, and then we're going to get to 98. Number 7, 8, and 9, as you can see, there's already some writing here. Like I said earlier, we are just interpreting. The keyword here is when we want to interpret the confidence interval. Everything is given to us here, so we're just interpreting it, that we are blank % confident that the interval falls between what values and that contain the true value of mu. So as you see, I kind of already wrote those out for you there. We're just kind of following the same script as before. Now, the next problem here, let me just check and see my time real quick. Don't have very much time, but we're going to try to tackle it real quickly here. So, hopefully you read it all. And once again, big things that here is that it's a population that is normally distributed, which is great to know, but the standard deviation is not known. So truly we should be using t-values. However, I like to kind of keep z all together, kind of stay in the same table, get really comfortable with z's, and then we'll move to t's later on. So I'm going to be doing both here. So if you ever come back, you can look at it, because we're going to be doing the same thing when we're trying to find our e. So if we're trying to find our e, so e using our t-value is going to equal t alpha over 2, which is just finding the t percentile at that part for an unknown sample standard deviation over square root of n. And then if we wanted to use z of alpha over 2, just to use the same table, we're doing very similar, same things. Once again, I said we would go through both. But if we know that the population standard deviation is not known, we should be erring using a t. But I like to keep everything kind of in one area, so I'll kind of do both for us here. So if you ever come back to this video later, you can see the difference. Well, we know our n is equal to 12. X bar, add up all the values of x divided by the total number. Sorry, x bar is 297.4167. Standard deviation 213.2478. Once again, hopefully you're using technology and calculators to get these standard deviations. Notice that standard deviation is a sample because the population is not known. So use technology, use graphing calculators, use Excel, use the things around you to calculate that stuff. We did it by hand earlier, but now we can kind of move on and get that going more. All right, so moving on to number 10 here. So our z value at the 90% confidence, or an alpha level 0.10, is going to be 1.64 times our standard error, which is 61.559. Remember, if the standard error is the standard deviation by the square root of n, it's going to be the same for both, but our t value is going to be 1.796 times the standard error. And so we're going to get a little different values because of how the table is interpreted based on whether or not we know the population standard deviation. In most situations, we don't know the population standard deviation. Most of the time it is not known because we normally don't have the whole population. So when you write those out, with those are the margin of error. We want to do our confidence interval now, construct it for it. Oh, hold on. Got like 1 minute to finish up. So when we calculate our confidence interval, I'm just going to kind of do this little shorthand. Remember, it's going to be our x bar plus or minus the margin of error. But when we use our t, which is the one we should be erring towards, our confidence interval will be 186.9 to 408. And the z confidence interval will be around 196.16 to 398.67. Remember, we're going to be erring on the side of t, all because we don't know the population standard deviation. However, we're not really covering t very much. The book does, so if you're following along with the book, going through it, you can certainly use it. It'll definitely be labeled and more clearly in like tests and quizzes for you. So I've done both here just to kind of show the difference. All right, I'll catch you all in the next video.